Hello, hello, hello. This is David D. Hilster. I'm a little late. I'm trying to connect up with my headphone, my AirPods, and my microphone, but I'm here. I've been preparing hours for this. It's going to be a great day. You don't want to miss it today. It's all going to be about Aether, and I'm not an Aetherist, so that should be fun. But no, it's going to be a great day. The good, the bad, and the ugly about Aether. Hello again. This is David D. Hilster. This is the Saturday Science Chats, and it is sponsored by John Chappell, Natural Philosophy Society, and the Dissident Science Channel. I want to welcome all my subscribers. Today is going to be an amazing day. You don't want to miss this. I've been planning this for quite a while. Got a lot to talk about. A lot of information. We may even have to do two on this. And also, I've got 3 talks all lined up, and we're going to talk about that as well. So let me share my screen, because I ran in here. There we go, screen 1. There we go. We are, again, Saturday Science Chats, and sponsored by these two great organizations. Again, I want to welcome all my Dissident Science YouTube subscribers, and of course all the subscribers to the John Chappell Natural Philosophy Society. So let's go forward. And again, people ask me, why do I do this every time? Because this may be the first video that you see of this broadcast Saturday morning science chat. So the CNPS, what is that? That's the Chappell Natural Philosophy Society, named after John Chappell, who founded the Natural Philosophy Alliance, which became the CNPS. We're an organization that above all promotes critical thinking without malice. That to be an organization that supports, publishes, and promotes serious scientific work outside the mainstream. Yeah, if you don't believe relativity right, or the Big Bang right, or particle physics right, or have a new model of the universe, you can come here, and this is a serious science organization. That's the way it should be. I mean, no offense, people. This is the way science should really run, but it doesn't. So that's us. To provide a forum for open debate about modern topics in physics, cosmology, philosophy, and mathematics. To provide a forum for presenting serious papers and theories without fear of censorship. Boy, that's big, huh? To be run and controlled in its entirety by its paid membership, including the election of directors and by its members. How to participate? You can sign up on naturalphilosophy.org. You can consider becoming a member. Talk a little bit more about that. You can participate in our community discussions on our website, and also post news and happenings about us on social media. Our websites, of course, are the naturalphilosophy.org. Natural philosophy is what people called physics and cosmology before there was the words physics and cosmology, which really came in the 20th century. So we are going back to our roots, and that's why we use natural philosophy, because we think the philosophy has to come back into our science. And then, of course, we have our online magazine. So if you are sort of a layman and you're not a super uber physics or cosmology nerd, but you love science and want to know what the heck is happening, what are people doing outside the mainstream, go to our online magazine. Very popular. Got lots of views on that every day. We have a Wikipedia, because, of course, Wikipedia doesn't allow for people to put in knowledge of alternative ideas. They call that pseudoscience. Their idea is to give the consensus of everything. So you're going to go find nothing that's on the cutting edge there, unless it's technology. Then for some reason they make that distinction. And then, of course, we have our Chappell University, which is going to be coming sometime this year with our first courses in natural philosophy. We do have our new members, and we want to thank them just this week. Herman, I'm not going to put their last names, have an annual membership, and Christopher came in with a monthly membership. And you can see there's a lot of active members. We actually have over 70 members now. This is a website that's new. This isn't 70 members worldwide. Our organization has over 300 members, active members worldwide. It's just this is our new website where you have to come in and re-register and all that. And you can see these are the recently active members. And they also, you see the group on the website. You can see the active groups: Big Bang Theory, Expansion Tectonics, one day, 12 hours ago. So you can see where people are talking, and these things move, so it means it is active, and that's what we want to see, of course. That's the idea. And I do want to thank what I call our patrons, out patrons. Let's see here. Hold on. I'm going to go back here and correct it on the fly here. Our patrons. Here we go. Our patrons. Don't you love this editing on the fly from Current Fly? Oh, there we go. It's right. Don't out the patrons. Well, I'm outing them because they are really important to our organization. They have given us good sums of money to keep us going. Dr. Cynthia Whitney, who is our chief CNPS officer, chief scientist. I got to get her on. She's getting old now. She's in her 80s, but she's got her degree in special relativity from MIT, applied it to ring gyroscopes, and it failed immediately. And she went back to her professor at MIT and says, hey, relativity doesn't work for, you've probably heard this, but I'm going to say it over and over. We have a story about it, by the way, on Science Woke. She tells her story about that. So you want to go to sciencewoke.org. And she said, well, how come special relativity doesn't work in the real world? And she goes, well, everybody knows that, but there's not much you can do about it. Well, you're in the place where there is something you can do about it. Duncan Shaw, he is a member for numerous years in the last 5, 6, 7 years. He's been generous when we've needed some money. We've got an anonymous donor. I will not say who. I want to thank him. I will say it's him. Robert Hilster, my father, has donated to his son's causes. No, he's a member. He's helped out, and also Kurt Renshaw recently. And these are people you can donate on our page. You don't have to have a membership. You can just come in and make a donation. We have a lot of expenses. If you want to look, you can go to our memberships, paid memberships. If you go to the top of our website, you can see right here. Let me get my pointer out. Okay, here we go. A laser pointer. There we go. If you come up here and click on members right here, you can come down and pay memberships, donate, and you'll see something like this. And now I've even made a subdomain, we call them. Instead of www, you can go to membership.naturalvelocity.org. And yeah, you can even look in the bottom there, right down below. You see that? The running banner. Thanks to our StreamYard, which we pay a fee to have this great service. So you can see that running down the bottom. It's just like, a telethon. But you can do monthly, $5 a month. That comes with $60 a year. $10, $25, $50 a month. Membership Basic, which are the yearly memberships. And again, there is a donation. There is a donation button as well on our pages. The CNPS chatter lately, you got to go and check our website out. You got Stefan here just talking, he's talking about Doppler effect and force fields, explain the relativistic mass illusion, and that's in the form of new models. And he's talking, Herman, these are newer people, and I welcome all of you guys and gals who are joining us. And then, of course, we do have our email chains, which unfortunately I try to talk to them over and over and over again. I said, you can go onto our website and talk. Well, I don't know why. You're missing out a lot. They're talking about gravity and ether, which is a great topic for today. I really wish these people would share, because I think there's a lot of people who can contribute to the conversation. Of course, I think you can make them private, but control who's actually in the conversations on the website. But again, there's a lot of chatter. So orbit precession turned into talking about ether and gravity, and you can see this, and you can join in, because when you go to the website, you're going to be able to see that right on the website. Oh, see what I do? I'm so smart. I never remember to play the bumper. So we have a lot of great things coming up. So what does it say, David? Play coming, bumper, whatever is that? Blumper, stinger. There's a lot of words for it in the vernacular of these little short videos. But here's what's coming. Yeah, people always say, hey, Dave, you always put your face in there. Well, guess what? In today's world, you got to have a face to what your organization or what you're doing. You got to have a person out in front, and I guess that's become me. I don't mind it. I'd rather be just doing other things as well and then coming to these myself. But for now, it's me, and I'm out there hopefully representing everybody really well. I have zero ego. I mean, even our own book and our own theory, I doubt 17 times a day. So I'm looking for truth. I'm looking to help people become critical thinkers. I'm a person who really, I think people know that, I support everybody. I don't have to agree with you. I don't have to even subscribe to your model or ideas, but I'm 100% supporters. Like Electric Universe. I'm not an Electric Universe person as much as I am more Newtonian. And do I say, oh, Electric Universe people are wrong? We have a tendency in our organization to get on each other's case. That's not the right thing to do, folks. I've talked about this many times. It's not that it's, we're fighting mainstream. We're fighting the Big Bang. Nothing big. The Big Bang, particle physics, relativity, what gravity is, what light is, all of these things, quantum mechanics, and we got new models of the universe. And we expect people to listen to us if we don't even listen and support ourselves. So that's why I'm here, myself and Greg Volk. I think we're the biggest advocates of that, and we are out there to make sure everybody becomes advocates and people to become like that. And that's really an important thing to do. So let's keep going here. And here's a page from I think this is an older page. I make these slides and I copy these slides and everything. So let's just move forward. That was wrong. Coming here, we do have a date, folks. This is coming next week. And if you don't know Dr. Alexander Unziger, you need to know Dr. Alexander Unziger. In my opinion, he's one of the foremost advocates of critical thinking in the real particle physics world. He's a physicist. He's a physics, a science journalist. I have this idea that we're going to watch a video that he did with a Nobel Prize winner from the United States, and you're going to see him sort of not be taken down, but get more frustrated with Dr. Alexander Unziger's question. So he has access to the top people in physics, Nobel Prize winners, and he goes and writes books like, oh, The Higgs Fake. And if you haven't read The Higgs Fake, then you don't know what's going on in particle physics. I don't care if you subscribe to everything that goes on, but if you haven't read The Higgs Fake, you are not up to date on how precarious and horrific the science, the engineering, and the software they use for doing particle physics. It's pretty much a game where they get what they want because of the way they do filtering, for instance, of what they call noise. You can imagine the particle physicists filtering out the noise. But again, I've said this many times, if you were to send NASA, SpaceX, engineers to the particle physics room where they do all of their engineering and scientific work, they probably last 5 minutes, 10 minutes, maybe 2 hours max before they realize this is bad science. But again, you should read that. The Higgs Fake is really well worth it. He also has the book Einstein's Lost Keys. He's also writing a new book. I've been communicating with him, but he is an amazing mind, and you don't want to miss him coming up very shortly. Also, what happened? Did I do this wrong? Okay, yeah, I did. Sorry, folks. I've got so many slides this week. That was wrong. So pretend that didn't go by. No, anyways. Then coming up the week after is Jack Kuykendall. So Jack Kuykendall, I'll just say it that way. And he has symmetry math. Now, he's been here. He may be here. If you are here, Jack, I'm looking forward to it because he sent me his document on symmetry math. And if you are there, Jack, I'm a mathematician. In literally 30 seconds, I got it. And it is fantastic. If I can get it in 30 seconds and I'm not like, Mr. IQ, anybody can get it, and it is amazing. It blew my mind. It was the second time my mind was blown with a system other than the system with Peter Erickson and the veritable number system. Fantastic. You don't want to miss that one. And of course, we got another one lined up already too for February 13th, and that's going to be Nick. I know he is in the green room. I love Nick Percival. I can talk with him for hours. He is a fantastic mind, very articulate, And he is probably the foremost expert in our group. Well, he is the foremost expert in our group on relativity and time and all that, and the nick of time. And if you haven't gone to his YouTube channel, you should. That's what was going back there. There's his YouTube channel, Nick of Time. Check him out. It's got lots of great videos. He's going to be putting together a video for us, and we're going to watch that live all together, and then we're going to have question and answer, and I'm sure there's going to be a lot of discussion. Nick is just a great member. He's also helped out with our organization quite a lot, and greatly, greatly appreciated. So we got these things lining up, folks, which is great. And of course, coming in 2021 is Steve Bryant review. I did this review of this. I didn't. I think it was Glenn Borkert. Glenn Borkert's a big supporter of him. So, I just trust. Well, I don't trust people, but I'm kidding. Glenn Borkert, who I of course many of you know, I really admire for his work with Infinity and Neo Mechanics. He also helped and worked with Steve Bryant, and he has come, and he might be here. If you're here, Steve, great, and looking forward to setting a date for that. And of course, as Alexander Unsker sits here he's got a great website, check him out. But he always says, keep working on your passion, folks. That's what we're here, and we are here to support you with that. You can see we have people coming up that are passionate about that, those kinds of being critical thinkers. That's what we're all about. Our goal here is not to tell you what's right. Our goal is here to demonstrate that you can challenge mainstream, and that's what we should be. We should be doing this in universities, folks. This shouldn't be some organization that has to do this on the side. This should be the way science and teaching science should be, but it's not, unfortunately. So, all right, let's get to our topic: Aether, the good, the bad, and the ugly. And of course, I got another bumper to play. Wrong one. Oh, good. I can stop that right in the middle. Okay, here we go. Let's try it again. Bumper. Yeah, so I want to first clarify my opinion right up front so you know where I'm coming at. I'm not an aetherist. I think there are better models in my opinion. This is my opinion. But be careful before you go running and cutting my head off. I support 100% all aetherist work. I help people. Jeff Yee is a good example. We're going to look at a video he made, actually. And, I am absolutely 100% on board with helping them out. I read aetherist work all the time. I think of it every day, comparing it to our particle model. No, it's not a photon model. Okay, our book, I'm taking a week off, and my father and I are going to finally finish our book. It's mostly graphics right now, and then we're going to give it to 2 people. We're going to have edit it. Then it's going to be available, and then we'll talk about it. That's probably going to be, February, March. So no, our particle model is not photons, okay? That's all right. Anyways, pet peeve. I think about it every day. I really do. I think of Aether, is that a better model than the model we have? It's very different. Most people don't understand our model. That's okay. That's why we write a book. But I do think about it every day. And Aether could end up being the model because we are still in model revolution. If you don't know what model revolution is, look up Dissident Science Model Revolution, and you will find a video that I have made on why we are in model revolution. So again, this is just my opinion. I am not an aetherist. I do support them. I think about it every day, and it could be right. So there you go. That's one of the things I will tell you. I don't hear many people who have models saying that other people's models could be right and theirs could be wrong. I almost never hear that. My father and I say that all the time, but I mean, that's not a good attitude, and I think a lot of times we attribute people like Einstein. I talked with, one of the friends of Einstein, and reviewed him for my movie, EinsteinWrong.com. Go to EinsteinWrong.com, check out the movie. But, we always imbue, I asked my mom during the filming of Einstein Wrong, which took about 8 years, I said, Mom, do you think Einstein thought that his relativity could all be wrong? And she goes, yeah, I think he would. So we imbue that upon people who we admire, but I don't hear that. I rarely hear a person get up there and says, this is my model. It could all be wrong. Never hear that. I don't know why. Because that's the truth. Actually, no model is right. We're just less wrong, maybe, than other ones. So, okay, the state of Aether among critical thinkers today. Most all model builders in the critical thinking world are aetherists. But many people are on the fence. That is, remember, model builders, not members. Not all members. Most members are not model builders, so that's a minority. There's a minority of people in our organization and people around the world who are building actual models of the universe. And of those, the majority are aetherists. Well, I have some ideas why that is, but many people, of course, are on the fence. If you, Ray Gallucci, he's one of the people who will do papers on other people's theories and says, is the ether theory by Duncan Shaw, which I call the Vancouver ether theory, because he's inspired in Vancouver by the mists coming in and out, and he's got ether that travels in and out. That's cool. It's an interesting theory, but he is a person, one of the people that has this theory, but we have other people who, like Ray Gallucci, who did his paper and said, okay, is this a possibility to work? And he'll do that. So Ray Gallucci, if you ask him, are you an aetherist? He goes, I'm not sure. So we have, and there are a lot of people in the organization that are not. There are a sizable group of critical thinkers who do not subscribe to ether theories. That's true. It's not like everybody in the CNPS or the dissidents all jump on the ether theory bandwagon. It's not true. But there is another huge amount, and again, this is observation. I don't have numbers, I don't have a survey, but I've been around this group 30 years now. Since in my 30s, I'm 61 now. Many people assume there is an ether, but truly don't investigate enough to take a stand. That's true. There are just so many people who say, well, yeah, I believe the Big Bang's wrong, relativity is wrong, black holes aren't what we think, quantum mechanics is problematic, I believe in expansion tectonics, all that stuff. And, oh yeah, light has to have a medium. Again, that's an assumption. And yeah, it must be ether. But then if you ask them, have they investigated everything? And no. And I actually claim that, I am actually claiming that a lot of aetherists don't investigate the problems of ether. They just ignore them because they're just hell-bent on, it's right, it's got to be a medium, that's the only model out there. Okay, here are the new physical models comparison. Someone said, hey, Dave, you had X's there. They should be check marks. So actually, I couldn't find a check mark, so I have a square root sign. I'm sorry. Got to keep this entertaining. But you have the infinite universe, all the theories across the top here, infinite universe theory. That's, again, these aren't all the theories. These are the ones I know about. And these are the more recent theories in the last 5 years, basically. Infinite universe theory, that's Mr. Burkert, Glenn Burkert. Energy wave theory, Jeff Yee. The OM particle by Laurie Gardy, the new, I've changed this, it's the new ether theory. And then, of course, we have the particle model by Hilster and Hilster, all Newtonian, all light, all no charge, ether, up, look at there we are, Dave and his dad just aren't there, you know. And Glenn Borges says, you'll come around. That's okay. And then the magnetism is really people who have, Denew, et cetera, et cetera. But again, these are, you can see right here, this is the crucial one we're going to be talking about today, is the ether theory, and everybody's an aetherist but us. There's other people, too, that have models like lattice models, which are not ether models, which are also viable models for light. But people, for some reason, don't see that. So what I'm going to do today to get us sort of kicked off is we're going to look at Jeff Yee. Jeff Yee has his energy wave theory. I remember when I started my Dissident Science YouTube channel, he is going up there and going up there. He made quite a lot of videos. He's very articulate. He's very calm, not like me. He's like, you know, I'm all over the place, can't finish the sentence because my brain, I claim my brain thinks faster than my mouth works. Maybe that's not true. It's just probably, you know, I don't know what it is, but anyways, I love Jeff Yee's work. I love Jeff Yee. He's a really calm guy, really deliberate, has a great theory out there. Again, an ether theory, an energy wave theory. I mean, here I am, and I'll support him up and down. He could be right. You know, one of the things, don't burn your bridges, folks. make sure you keep your friends so that when, they could become famous, that they'll still like you. I don't know. Where am I going with this, huh? But anyways, Jeff Yee, and you should check it out. Subscribe to his channel. It's really great. Let's see. He has some. He has these videos, which are actually very good videos. I think he's calculated them, and those are videos that are just about general topics, which is a good way to get people to your YouTube channel. And he has my top video has maybe over 20,000 views, but it's on special relativity, and it lambastes. I mean, it just rips through. I mean, special relativity. In fact, the likes and the likes are winning, but there's a lot of dislikes. So I'm a little different. I'm not into myself, doing videos on, what is Aether, or, what's annihilation. But Jeff does it, and he does a really great job to give you an idea what it is for. And of course, the idea for him philosophically or marketing wise is that if he does these videos, people will be interested, and maybe they'll come and be interested in his model. He's just not a giant pusher of like, my model's right and everybody's wrong. He's a very calm guy working on passionately about what he's doing. Again, I like that. So we're going to take a look at his what is Aether, and I am going to start playing this. So I am going to I'm just wondering if I should do this via I'm gonna try it. So what I'm gonna do is I'm gonna try it. People in the green room, Ian, Nick, Franklin, you let me know if you guys are hearing the audio. Give me a thumbs up right away if you do hear the audio, because this is being played from the internet through the slide. I have it up here, so in case this doesn't work. So please give me a heads up. So I'm gonna click on this. And please, okay, I know Franklin will be quite quick to tell me here. Okay, down. All right, I do hear it. So we're gonna go. Good. Thank you guys. I'm going to. Whoops. I'm going to go to this here. We're gonna bring this over right here. I'm going to bring this to here. Oh, you know what? I know what it is, probably. I didn't. I'm going to have to take this all down. Sorry about that. And I'm going to share my screen. Stop sharing. I'm going to share the screen. And I have to click on shared audio. That will help. So I will do that. And I think we should be good this time. Here we go. And please, again, give me thumbs up or down. Whoops, it's because it's muted. How about I start again?
What is Aether? What is Aether? And I should actually more specifically call it what is the Aether. And if we go back to early times, early Greek times, the word comes from Greek mythology, where it was the essence, the air that the gods were breathing. Anyway, Plato and Aristotle used it as they defined the elements, at that time 4 elements. Medieval philosophers continue to use this idea of the ether as a 5th element, and they associated it with the motion of planets, moving around space, and space includes an ether with a known density. By 1687, Sir Isaac Newton published his famous works on gravity, and he used the ether as the medium for explaining how gravity worked. Now, Newton also did a lot of work on light, which has known wave properties, and he used the ether, again, as the medium for moving waves. But a few centuries later, an experiment was conducted by Michelson and Morley to detect an ether, and the experiment used something called an interferometer. Now, the bummer part about it is it failed to detect an ether. And further experiments, even beyond Michelson and Morley, which also used interferometers to be able to detect an ether, also failed. So it showed there was nothing wrong with the experiment or the apparatus that Michelson and Morley were using. It just said, hey, there's no ether. which meant by the 1900s, physicists had to conclude that the ether did not exist, and they built particle physics theories without it. But if there's only empty space in the universe, and light has known wave properties, the question is, what is waving? The answer in physics is, all right, light is a particle, it's a photon. But that still is problematic because in that photon, there are still wavelengths that describe light and other types of waves. Light has different colors, red versus blue are different wavelengths. So still, even in a photon, something has to describe what causes those different waves and wavelengths. And every other known wave has a medium. A medium is a substance which allows the wave to travel. A sound wave travels through air, a water wave travels through water, an earthquake, a seismic wave travels through earth, the material of earth. We'll get into a little bit more detail here. A water wave is the motion of water molecules, literally H2O molecules. It's a vibrational pattern. And a sound wave is the motion of air molecules. Air is the medium in this case. And so if every other wave has a medium, we have to ask again, does the ether exist? And if it does exist, why was it not detected in experiments, including the Michelson-Morley experiment? And the explanation starts with this. Right? Shortly after the Michelson-Morley experiment, Hendrik Lorentz suggested that the experiment, the interferometer, failed to consider length contraction. By the way, this is a Nobel Prize winner, and the Lorentz factor later was used by Einstein in relativity, and it can explain length contraction. Now, in the late 1800s, early 1900s, it would have been difficult to build an experiment that considers length contraction, but computer simulations now are able to do it. And what we see here on the left is exactly what Michelson-Morley witnessed. There was no phase detection in the wave, in the light wave for the splitter there. But if you consider an interferometer that is in motion, you do see that phase detection as a result of length contraction. And remember, the Earth is always moving. It's the cause of length contraction is that not only is the Earth spinning, but it's also going around the sun, it's going around the galaxy, but more importantly, it's moving at a very fast velocity in the universe relative to other galaxies. And while that doesn't prove an ether, it could explain why it was failed to be detected. But this is the reason why I am so passionate about the ether, is this simple equation. This simple equation in energy wave theory calculates particle energies, calculates forces, but without it, without that one symbol that you see there that is highlighted, everything fails. There are no calculations. It is not possible. And that symbol is a density property. And density implies waves that are traveling in a medium. It's a given mass per volume unit. So perhaps there is an ether. If the ether does exist, here's the strange thing about it. More than a century of particle physics has been built on a missing but extremely critical property of the universe. And even this man, Einstein, he was not opposed to the ether. In fact, he's quoted on a handful of times saying that the ether could exist.
It's really great now. They put the unmuted right next to your name so you can you see it. So that was a really great video on the on Aether put together by an aetherist, obviously, and that was Jeff Yee. And I think it's got a lot of interesting things in it about the history. It does say one thing that I disagree with, and well, it's not that I disagree with. This, in my opinion, is wrong, which is every wave happens is in a medium, and that's not true. In our model, we don't have that, and it's disproven in some sense by everyday electronics. All the stuff you see and all the stuff that you're watching right now is actually sent through a digital meaning. It's sent in pulses, in waves of things, not in a medium. So, you know, that's the only thing I would quibble on that. And that's one of the, I think, problems. One of the problems we have with people who are only can think of ether is that they think the only way that waves can be manifest themselves is through a medium. So that was really good. I really think Jeff did a great job on that. Hello. There we go. Here's the logic behind ether. Oh, I was talking about slides and I'm not even showing them. So what an idiot here. Okay. All right. The logic behind ether. Light must have a physical explanation. Photons are not waves and light is a wave. And that's true, the photonic model. It's not a particle, folks, because what we say is one particle. It doesn't care if it's a photon, can't do it, but more than one particle can. But again, that's a different story. But this is what I would say the logic behind ether. Light must have a physical explanation. Photons are not waves, and light is a wave. Waves happen in a medium. That's the one thing that people say that's the only way it can happen. That's not true. And I think that's where etherists don't understand other models. But that's okay. But that's what you saw in his claim was that. So yes, and light must be a wave in a medium, therefore. So that was his conclusion. And that's what I see the logic behind that. So the good of it is there are lots of critical thinkers are working on ether models today. The vast majority of modern models are ether models. I can't read my own stuff here. So that's the good. The bad is mainstream has rejected wholesale ether. Michelson, Morley, and Einstein are mostly to blame for that rejection. We also have this problem of the wave-particle duality problem. Einstein actually brought that in. He got his Nobel Prize for the photoelectric effect, and that's when he said there's this thing called a photon, and then is it a wave, is it a particle? And there are many objections to ether models, and that's true. The ugly is, and this is what I see as the ugly, is dissident scientists ignore the problems with ether in favor of it must exist. And that is absolutely true. If you go back 30 years, 25 years, and you would sit in the same meeting, which of course we didn't have all this internet, easy stuff where people around the world can watch. Etherists were not in favor at that time. Now, and in my opinion, it's not that because, again, I think there are better models, but I'm not saying that ether is not right. I mean, we've been trying, 300 years, 400, almost 400 years with ether models. Still haven't gotten it right. But it could be that someone's going to come up with what was right. But there are, they ignore problems. It's like no one discusses that. And if you bring those up, it's almost like someone just talked Greek and you don't know Greek, and you look at them and go back to your conversations. So not good, in my opinion. That's the ugly part of it. Many etherists insist on making gravity as a result of ether. Now, I don't know why that is. Maybe I know that Jeffy talks about that happening with Newton. Newton was looking at that way. I have a question. I'm always wondering why. Well, ether really is more of a light idea. Well, we'll talk about that. And etherists don't recognize there are other viable models. They just don't. I mean, I don't know why. If I were an etherist, I'd be reading the heck out of what my father and I's model for light is, and not because we're right and you're wrong. It has nothing to do with that. I look at every etherist, every model that comes along, every one, because my fear is like, well, we're working on something here. It's our model, but maybe this person whose book I'm not reading, whose theory I'm not looking at, may be the one. This may be the guy. This may be the gal. And I'm sitting there Yeah, particle model's right, everybody else is wrong. Particle model's right, everybody else was wrong. I mean, folks, etherists should be saying, I subscribe to an ether model. I know there are other models, but this is why I do it. They also be saying, these are the problems, and I don't address them. I don't care. At least they know they're there. Or I do try to address them. Some of them do. Some of them do. Like Glenn Borker, who's been around and during the Ether World Wars, I call them in the MPA. Old definition of ether is somewhat of a stationary medium in space through which the Earth and other heavenly bodies travel. The new models is like a medium in which light waves are produced and transmitted. New ether models can claim to solve, for instance, transverse waves problems. Again, some like Glenn Borkert claims that ether particles are like, let's see, if I can do this right here. Sorry, I need somebody to. They're like galaxies, and so they're like this. So the transverse waves can be gotten by that kind of shape. Anyways, he's addressing it. And the problems with ether. What are, again, I'm not an etherist. You can see I have the ether up here. This is the, over here, the iceberg. And then down here, all these problems that like mediums cannot transmit the transverse waves the way we need them in light, and there are people addressing it. This is one of them they are addressed. Another one, there's an immense elasticity in order to transmit waves billions of light years. So you have a galaxy that's 10 billion light years away. That transmission is happening through collisions for 10 billion years. They're smashing it. It's like billiard balls. And in my opinion, that kind of transmission, look at sound. Sound goes what? It goes not very far. You're lucky if you get a sound to go a couple miles, maybe. It's not a great way to transmit data. We're not using sound to transmit data. Yeah, we're using light, Dave, and then we're back at circular. Yeah, but it is a problem. I know Ray Gallucci calculated the elasticity, but you'll get this one a lot from mainstream science, and it's a valid question. It's a valid question. Lasers. If light's away in a medium, I'm going to have in sound, and I'm going to project this sound that's 1 inch wide, and it's going to go only to you. And it's not going to hit 2 inches to the side of it. That's what happens with lasers. Now, how do you have a medium do that? And this is one I've come up with. So I call it voices in a crowded room problem. And that is data transmission problem. If you have like a room, imagine you're in a room, you're in a one of those big domes where soccer is played or American football is played or whatever. And you got 100,000 people in there and they're all talking. That's all being transmitted through sound. How much data can you get through that medium? That medium is going to have to be really small. One of the things is Glenn Borker, I think, is trying to address this because he says that ether is the size of like 1 trillion ether particles can fit inside an electron. So he is trying to do it with an immensely small particle. But that is a problem. So the types of ether that we have are luminous ether, entrained ether, flowing ether. Luminous ether is the idea that the Earth is traveling through this, ether in the universe, and that's why Michelson Morley said we're going to be kind of finding that. That's the oldest kind of idea of ether, and so we're like, we're a ship in the water traveling through the water, or we're a plane going through the air, and the air is the ether. Then you have entrained ether. What is that? I hope I spelled these things right. I'm a linguist. We don't spell very well. Entrained ether is the idea that ether actually becomes not glued, but sort of around bodies. It's thicker. So an ether, entrained ether is one of the explanations that Glenn Borkert uses. He says he is an entrained etherist, meaning ether isn't just a medium everywhere and it just sits there and we're traveling through it. That ether actually gathers around and is attracted to, and it has to do with Newtonian motion. And he explains that. Then there's also a flowing ether, like Duncan Shaw is one of those people who says ether is flowing into bodies and then actually goes back out. Of course, it's got its own set of problems, but he's also working on that. So those are the kinds of ether people are working on. And ether explaining gravity. I mean, why? Is this a requirement? I don't understand that. So anyways, I think the most important thing for us to try to deal with today is understanding what ether theories are, understanding what the philosophies are. And I've got these big questions up here, ether explaining gravity, but we'll just take them one at a time because it's hard to get them in order. There's just so many things. So I got people in the green room. I want to know, especially if you're an etherist, if you are a person that believes in ether, is it necessary that ether explains gravity? I think what happens, in my opinion, is that ether is definitely something that's light-centric, in my opinion. Ether is something that people come up with to say, we need a medium for light. That's what ether is. And so that's cool. That's fine. But then they come along and say, okay, now I've developed this thing with ether. Oh, maybe that because we don't have a gravity. So, okay. Hey, Mr. Franklin Hugh, you put that up there. And anybody else in the green room, would you like to come up and talk about that? Again, I'm not here to say this is wrong. I'm not here to argue against it. I just think it's strange that if you have a light-centric idea, which is ether. Ether was not, I mean, even, yeah, Newton, I don't know about if Newton truly was looking at ether for gravity because there's a graviton model. It's kind of murky, but regardless, most people, when they think of ether, that what they're thinking is a thing for light. Why would they insist that gravity has to be a part of that? So I'm going to bring you up, Franklin. There you are.
Hello, David.
Good morning, Franklin. How are you?
Good.
So go ahead. I'll give you the floor. It could be if gravity is a form of light, but first of all, you are an etherist, right?
I am an etherist.
Yes. And so tell me. I'm sorry?
Are you getting an echo? Just a second.
No, I'm not getting an echo because I got my earphones. Yeah.
Okay.
Yeah, you're kind of alien sounding right now, so I'm not sure, but it could be that you're an alien. But
it could be that. I could agree on that.
Yeah, it could. So why don't we get back here to discussion? Tell me your idea. Being an aetherist, are you a person that just says gravity should be part of an ether?
Well, I mean, a lot of theorists directly use the ether particle as a pinching on the top of my head to push me down. I don't believe that. But it is intriguing by the idea of ether being a light phenomenon. And in my hypothesis, gravity is essentially electrostatic. And electrostatic arises from electrons and positrons emitting a very high frequency, light. And so eventually it all comes down to that thing that pulling me to the chair is actually a form of light. Because there's all this light coming from every single particle in every body. And that is causing us to stay stuck under the chair.
Okay, yeah, I mean, I think there are a lot of different models out there and ways that people will, in fact, try to describe gravity with ether. It's just my question is, I'm going to bring you back down. Thank you for your comment. My question is why do you think, again, I look at it and say, okay, ether is the light-centric. Why do people insist on putting the gravity part of that? Anybody in the green room want to? Okay, good. I got two people. Ian, how are you? Good morning or good afternoon.
Well, according to from there, Thank you, David. Right. Well, I hope there's no echo there as well. Echo again. Yeah. Well, I speak slowly. For my, I restrict my analysis ether to the luminiferous ether, which is really a bit of a tautology, because ether, I mean, ultimately it comes from the Greek aether, which means to burn. So it's all about, light bearing medium. Now, my possible explanation for why so many people tag on gravity to it is they're aetherists by conviction, and they say, oh look, it'll explain this other phenomenon which has been heretofore inexplicable. But as I say, for my part, I look at this, which quacks like a duck. I mean, so therefore it must be a duck. It must be material. It has material properties. It has a sort of an electric permittivity, which is like an elasticity, and it has a magnetic permeability, which is basically a grossness, a mass, and I've also extended it, following maybe some earlier work done by Monty, to establishing, well, actually two. Monty establishes a conductivity of the ether, and I use that, the conductivity of the ether, and also resistivity. Now, I'm modeling, if you like, the ether as a sort of an infinite transmission line made up of series inductances in a sort of like a T element, and parallel capacitances. And the conductivity would be like a short circuit of the capacitance. So it would be a leakage, a loss that way. And the resistivity would be a series resistance along with the inductor. Now, for very high frequencies, such as light or radio transmission, when we're talking about electromagnetic radiation, it's basically the leakage which predominates. So you can neglect effectively the resistivity little element, and you have to take in this sigma naught, I call it, the conductivity business. And then, of course, if you sort of solve the equations, put it into the wave equation and so on, because basically what Einstein is saying, that sigma naught equals 0, so therefore there's like a perpetual motion machine that electromagnetic radiation is moving through space with no dissipation. But I calculate this dissipation very, very precisely, and I get something like it has decreased to 1 over e of its initial value after 10 to the power of 10 light years, I think it's something like that. So this is basically a tired light,
right,
phenomenon.
Right. I apologize for the echo, folks. It turned out that if you turn the audio on for showing your screen, it gives you an echo, because I looked it over down there and it was still, and I think that's where the cap. So I think everybody should be sounding good. So what you're saying is you've got it sounds very similar to my father. It was interesting that my father was part of a gravity group. And one of the things people were looking is gravity part of the electromagnetic spectrum? Right, it's just a really low frequency. It's just sort of like the least or the left over from all the waves going on. And for some reason, he did some calculations. It wasn't working out for him, and he came up with the model that sort of pushed us forward with our particle model. So then you also have, I don't know, did you notice and did you watch in Glenn Borchert's explanation of entrained ether? I mean, what did you think about that? I mean, that is a different kind of idea for gravity, where you have, the entrained ether and you have that ether that's closer, that has a literally just kinetic Newtonian gravity. Did you get that, or is that just?
As far as I remember those expositions, I basically I'm sitting on the fence. I haven't really come to any conclusion. I mean, I'm willing to consider it as a possibility, but I think all these sort of models of gravity, Lesage or Glenn Borchardt's, or all these particle sort of models, they're rather speculative, and I'm not convinced. And also, by the way, I make a distinction between gravitational waves and the gravitational force. So gravitational waves would be, to me, etheric waves. They'd be disturbances in the ether, which would be analogous to electromagnetic radiation, and they probably would travel at the same speed as electromagnetic radiation. However, the force of gravity is the interaction, the force, and that seems to be, more of an instantaneous. Newton obviously took it as infinite. Einstein took it as the speed of light. Well, I take it. I follow people like Van Flandern, who take it as orders of magnitude greater than the speed of light. I've forgotten exactly what it is now, but 10 to the power of 20 or something or less, because there's no aberration in the effect of the force of gravity. It appears that there's a pretty instantaneous force, which say can be measured with an accelerometer on Earth when you get objects in the sky. For example, when you get a solar eclipse and when you get the sun and the moon aligned, there isn't a sort of an aberration, whereas with light we get this aberration of 20
Okay,
minutes.
well, now I'm going to push back on that, because there's actually two experiments, one done by Chinese in China that shows, in fact, mainstream science says that gravity travels, most of the mainstream science, when they're asked, says gravity travels at the speed of light. Also, the two Chinese scientists during an eclipse measured gravity versus light, and they had a coincidence there. And also LA, and the LA anomaly also found that, and that is the LA anomaly was coincident with the light. And so what I'm saying is that there are several experiments done in the field with eclipse that show, in fact, that light and gravity are at the same speed.
Yes, well, this is still subject to some debate, and I have seen some of those arguments. But I work, anyway, the sort of mathematical models that I'm working on are based on gravitational waves being disturbances in the ether owing to gravitational vibrations traveling at the speed of light. But the impact of a force of gravity coming from a mass being practically instantaneous,
Right. There's a lot of people who believe that. Now, I have a question in general for you, and again, this is going back to our question. What got you from the leap of let's not discuss whether, why you believe there's ether or not. That's fine, that you are an aetherist and you've been working in that realm for a while. Why did gravity even get into it? Is that just something that, because you're working on ether, it was in back of your mind, and so you sort of started to think about it, and you could? Was it? I have this idea, and and I know, Ian, you're a bigger thinker and can understand this. I really think that we can become in love with what we're doing, and then I call it the theory that ate Cincinnati, like the cockroach that ate Cincinnati. It's this idea that he starts eating things, and he's eating in every. So the idea is that a person has a theory, and then all of a sudden they want to apply it everywhere, and not necessarily that it should be applied in that case. And like I said, most people who are working with ether are not working with gravity, but somehow they become so enamored with the whole idea that say, oh, I can describe gravity. I mean, I think there's a psychological part. Do you think that's a possibility?
Well, I can understand what you're getting at, David, in the question. And I think, I do think it's a possibility. And in fact, I'd go further. I'm not going to answer the question, because I think in my case, I have probably been influenced by that, by outsiders, maybe fellow etherists, applying, very readily the principles to gravity. And then I say, well, maybe I should look at that. But no, I haven't been influenced by that at all. In fact, I've rather, fallen back on Newton's comment that he doesn't actually know what the cause of gravity is at all. It needs some external hand to impress it upon bodies. He's just looking at the effect. So
right.
What you're asking this question as why people are so interested in gravity, it's sort of an add-on. They're saying maybe, hey presto, I can explain gravity by this Lewis type thing. But I've only been influenced to a certain extent in that, and maybe that got me thinking of gravitational waves. But no, I haven't been doing that at all. My ether is an electromagnetic ether.
Okay. Oh, no. Yeah, I got you. But it's an interesting thing. I think you agree, though, that it can be that way. I've seen, I'll give you an example of it. Again, I support very much the electric universe, but I think at times when you get into that sort of groupthink that everything's electric, then everything becomes electric regardless, that you lose that ability to say, wait, I'm going to step back. And, and people, in the electric universe will say, no, the gravitational is electric, everything's electric. And again, I come back and says, well, what does electric mean? Right. Again, in our model, we know we have literally a particle movement that says what electric means, no matter what level. I'm not saying we have the answer, but there's an answer there that I was totally unsatisfied. It's like, if you believe the universe is electric, what's an electric field? I want to know the physicality of these things. So, with an ether, of course, you have a physicality. Since you're up here and we're talking about you as an aetherist, I'm going to ask you a few more questions. How do you deal with lasers in your theory?
Well, I might have to formulate a theory on the hoof, because I haven't specifically dealt with it in terms of my theory. But I heard your earlier question about how this might be a bit of a problem. I'm not quite sure if it is a problem in having a sort of coherent light source moving in the ether. There would probably be some sort of properties that one would have to put into the model. But I don't think it would be ruled out by the ordinary model, transmission line sort of model, which is producing, or being the carrier of incoherent light which is not coherent.
But I guess I lost you a little bit there. You're making the transmission. Are you talking like transmission wires? I lost you there.
Yeah, I'm just hopping back a bit to my introductory remarks, where I look at, you see, basically, if you have something which has an effective capacitance per square meter, capacitance per unit length, capacitance per meter, and an effective inductance per meter, it's nonsense to say it doesn't exist. It has certain properties. So I say it quacks like a duck, it must be a duck. Now, but we've also neglected, so these two things together can give you a sort of like a resonant condition. But if you don't have any resistance or conductance in that, it's a perpetual motion machine. There are no frictional losses. There are no losses. So a transmission line basically can be modeled as a capacitance to ground, a capacitance to the earth, an inductance along the length of the cable. And obviously, when you're transmitting, the submarine cable 150 years ago wanted to reduce the leakage to Earth through this capacitive effect of the insulation. And actually, it was Heaviside really who came later, contrary to what Kelvin was saying, that really what you wanted to do is you wanted to make the inductive reactance equal to the capacitive reactance. And therefore, you'd reduce the losses in both cases.
Okay,
so
but okay,
ether in that way.
Okay, but okay. Here's a natural question. I would imagine. How do you? We don't have cables with lasers, right? I mean, you're talking about a cable, and that's a physical object. And one of the things is, I know, and Laurie Gardy, who's an aetherist, was working for probably in 2020. She spent a number of months working on the idea that ether is transmitting, the waves through a a wire and it stays within a wire, right? One of the problems is if you believe electricity to be part of the ether waves as well, how do you keep it contained in a wire? And she came up, the only conclusion she could come up was there was a new, literally elemental element almost in the periodic table she called electronium or something like that, and to keep that in there. But what you're talking about is a transmission through a wire. I'm talking about a laser, which is basically light going through. There's no tube there. Or am I misunderstanding what you're saying?
Well, I'm not quite sure if you need to go to a laser then to see this perhaps anomaly. I mean, if you have a radio transmission and reception, you have a radio wave which is going through the ether. It's wireless by definition. Now, that is modeled in this way as analogous to a transmission line. It doesn't have any wires at all. It's completely wireless, but it behaves in the same way because the ether has certain capacity effects, and it has certain magnetic inductive effects, which are basically allowing this to operate as if it were through a wire. And I imagine that a laser, which I haven't looked at in detail, would be exactly the same thing.
So are you saying that ether particles have like charge and all that kind of thing?
Well, I suppose what I'm saying is they're like they facilitate a circuit, so that if you put some radiation through the ether, there would be charges flowing. It doesn't have charge by itself. You have to incite it with electromagnetic radiation. But if you do, you would have charge carriers moving because you have capacitances there and you have inductances.
Okay. Okay. All right. I appreciate your comments. I think in this time, maybe you want to come back sometime and talk about, your model, because it's it takes some time to understand, but I appreciate your comments an ether person there. And I know Bob Gray, I think you wanted to make some comments as well. How are you, Bob Gray? Unmute yourself there.
Unmute myself. There we go.
So are you an etherist?
I don't know what I am.
Am I going to like you or not? I'm going to like you or not? I'm kidding. I'm kidding.
Any theory.
Whose side are you on? We're going to beat you up. No, I'm just kidding.
Any theory that follows a logical train of thought, I'm in favor of.
Oh, so you like consupponability in some sense too, which is the word meaning it's got to be self-consistent, right?
Right.
I mean, that's true. I mean, special relativity, there's a good inconsistent, thing. So tell me what are your comments on ether? Go ahead.
Yeah, a couple of comments for Ian. I don't know who it was first in history of modeling the vacuum or the ether as transmission lines and using transmission line theory to calculate the speed of a signal traveling through the ether. I seem to recall it had something to do with Weber and Kirchhoff. And so for the history of that, I'd look with those names. But it's my understanding that using Weber's instantaneous action at a distance electrodynamics theory and transmission lines, Kirchhoff came up with, or Weber came up with, the calculation for a signal to travel through that, and he comes up with the speed of light, even though he's using an instantaneous action at a distance electrodynamics theory of Weber. Okay, so you might want to look into that aspect. Another aspect for the transmission line is an interesting book, Electrical Solitons. And this is all about solitons and transmission lines and networks, transmission line networks. So the question of laser, how does a laser work? The way I envision that is that the atoms go into an excited state, and when they de-excite, it somehow generates a soliton, which gives it its unidirectional emission. It doesn't emit omnidirectionally. And again, coming back to this, if you model the ether as an electronic network, you can have electrical solitons. So those are a couple of things for Ian in particular. Now, for you, Dave, you say you have a particle model. You and your father have a particle model. I guess I'm not understanding the usage of the terminology ether. Because if you have a particle, I don't know if you call it a G1 particle or a couple of these particles, okay, what is the space between them? Do you label that ether or just empty space? And does that space have any properties?
No, ether is pretty simple. Ether means the transmission of waves through collisions. That's what it means. In our model, we don't have that. If you have light that comes from a sun, they're releasing these particles, which are we call electron, photon, graviton, and actually magnetic particle, a particle that causes magnetism, all the same. It's just releasing a bunch of particles, and they come in waves, just like bombers come in waves. If I send you bombers every 4 minutes, I'm getting waves from single planes. That's what we say. So the difference with ether is, and I know Franklin has said this, and it's not true. It's the definition of ether is there's a medium. You even heard it's over and over, and in that medium you have collisions. So the way you transmit is just like air, right? I mean, you have what's happening is you don't have air molecules that are traveling between, for instance, some sound source to my ear. They're not traveling. What's happening, there's collisions, and the ones closer to me will collide with my eardrum. That's what ether is. And that's what people refer to ether in the medium. Now, if people start moving from that, then of course, we're not even understanding what, that's, like I said,
I still think there's a language issue. Because I always considered the ether to be that which the particles move through. And so a magnetic field, an electric field, a gravity field, those are all particles, perhaps. There's particle trend. But what the particles are moving through is a space. And that is what I was thinking ether.
Yes, right. So you have because I'm a linguist, so we watch a lot about how people use words. I can give you the answer why you have that confusion. Ether was also used in a sense, in a colloquial sense, to mean that the ether of space, the stuff, So it has two meanings. But if you look at the physics meaning or the natural philosophy meaning, ether specifically is the idea that light is waves through a medium, and that medium is ether. So that when people say traveling through the ether, and I believe they even spell that ether the same way they spell ether, E-T-H-E-R, which is really, again, a misnomer because that's an element or a molecule or an element. Again, don't get me on that. But so that's where the confusion comes from. So if you look at it in a technical sense, you look at it in most etherists, they're going to say, I think that's non-confusion. I mean, since the beginning of luminous ether, and that is you have particles. And if you remember Jeff Yee's video, right, you could see the sound traveling. Those particles are only moving like this, right? That's all they're doing. And so there is that's the idea, is the wave itself is a force that comes from something next to me. So right here, I've got a molecule, and it's going to be hitting my eardrum because there are forces of it hitting to get there. And so when we are talking about it in our circle, it is not the colloquial out in the ether. And there is, and I really do think that comes from, if I remember the historic context of ether, of that, we are traveling through space, which people then call ether. So that's confusion.
Which is why I was a little surprised that you have not raised, but maybe you just answer it, you have not raised Zeno's paradox. So, to move from A to B, you have to move halfway between that, and then halfway between that, and halfway between that, eventually ad infinitum. And therefore, you can't move through the space or through the ether. Zeno's paradox.
Yeah, I understand. I know, and
that's why it's a little confused. You haven't mentioned that at all.
Well, because I think Zeno's paradox is a mathematical construct that a person came up with, and it's sort of like not a trick, but it's what I mean. Actually, I've got a book back here. You talk about going off subject a little bit, but it has to do with what you're talking about. There is a guy, because of my work, and I support everybody. Again, I'm if Ian wants to talk about his stuff, I will do what I can to help him get his word out, all that. So I support everybody. Well, if people know that, I'll get books out of the blue. And I got this book out of the blue from a guy whose father died in Canada, and he did slow motion photography. He basically was doing slow motion photography of a bullet traveling. After he did this for many, many years, he came up with this really amazing philosophical statement that movement was not infinitely divisible. Mm-hmm. Now, then if you really look at that, and I've got the book back here, it's probably one of the few in the world, but I can't pull it out because I've got so many back here. But in there, he talks about that. He really made a book on that. And so, yeah, so that's on Zeno's paradox and movement and time and all that. That's a
And then I was going to say that
subject. Yeah,
that kind of leads into the lattice models like James Keene's binary mechanics and all that sort of stuff. But it seems to be slightly different than Aether discussions.
Oh yeah, absolutely, absolutely,
so,
Bob. And
thank you.
Yeah, thank you very much. Thanks for your comments. And Bob did bring up, if I were to classify myself looking at this, there are basically, you have Aether models for light, which is basically transmission through collision. You have lattice, which is transmission through deformation. And then you have particle models, which is literally transmission. And again, particle models, not to be confused with a photonic model, okay, which is very different. So, all right, we have lots and lots of comments here. Let me go back to some of my, I've been talking about that. So let me, here's one. There's open space, no Aether peaks in between. Okay, yeah, there's my father was talking about, I think, answering a question there about what we have, which is there is open space, no Aether between peaks of G1 particles in the particle model for light. So there are peaks of the particles coming at you, and that's what in our model is light. That was just a clarification. It's not here to push any one or the other one. All right, somebody in the green room wants to talk about Aether. Please raise your hand. Any comments? We've got quite a few people in there. Yes, I have Robert Kemp.
Of course.
So, hey, hello, Robert. How are you?
Hello. How are you doing?
Very
David.
good. Well, welcome. I haven't seen you in a while, and welcome. I hope you're having a great New Year. So put in your 2 cents worth for Easter. Easter?
Aether, yes.
I can't say it. Go ahead.
I am an Aether theorist, and I've been working on Aether models probably for the last maybe 15 years or so. And but one of the authors that you bring up in Aether, you don't really bring up, in my opinion, you should bring up, and that would be Mr. Stephen Rado, who wrote the book Aetherokinematics, which is the seminal text in just about every, including you, your father, and every other Aether modelist that runs into this book, but they don't talk about this author. And yet every model that I have come across over the last 15 years involves the concepts that are in this book, but yet nobody talks about this author. I spent over 10 years spending time with Mr. Stephen Rado. We would meet sometimes at the Denny's in Beverly Hills, where he lived, and we would talk about this Aether. Now, he was the kind of Aetherist, he was a kind of an anti-Einstein guy. And he and I could talk about the Aether for hours as long as we didn't talk about Einstein's special relativity. So we built that relationship just because I'm not opposed to special relativity. I haven't found any errors in it like I find some people in this organization talking about. But nevertheless, in terms of the Aether theory, this particle model that you talk about is clearly delineated in Stephen Rado's model. He's using the same...
Are you talking about particle model, meaning the particle model of Aether, right? Is that what you're talking about?
He's using etherons to describe electricity, magnetism, gravity. He's using ether to describe all those. Now,
Right.
I have a
familiar.
particular model that's slightly different than that. I separate electromagnetism, gravity. There's this dark matter kind of material that's actually in there. It's in the mathematics. It shows up there, and we're actually starting to measure it with space-based observation telescopes. So that ether is actually starting to be measured. We're actually measuring it. It's just now we're trying to find out how to actually categorize. There's so many different ether models that are kind of out there now. But the general consensus right now is there is a material out there, whether we're calling it ether, whether we're calling it dark matter, but it's something other than gravity that is out there. Now, the actual model itself, in my opinion, Stephen Rado, another person that was out there before Stephen Rado was Dr. Frank Minnow. He was doing gyrons. And so all of that, because I've listened to you, David, you're aware of all of these physicists. You've been doing this for a long time. Matter of fact, Stephen Rado was one of the original NPA members.
Yes, I do.
And the ether was what I want to say popularized, hyped because of Stephen Rado in the NPA. So I would just like to encourage you, when you include all of those favorite persons that you like, the physicists that you subscribe to, that you think has the best models, remember that's only your opinion. And because that is your opinion, I would just like to ask you, because you're familiar, you have this history of these other
for sure. I know, I've met them.
The same history that you have concerning the ether that you're talking about. So when you leave Stephen Rado's name out and you talk about what is this Glenn Borkert, which is also, in my opinion, kind of taking / stealing / pulling ideas from that book and claiming those to be his own, without mentioning this Stephen Rado. He spent 40 years of his life studying, writing, documenting the ether. And yet nobody here is talking about him. And so that's the only reason I come up to bring him up, because that's unfair for that to happen after he spent 40 years studying and documenting and writing the ether. And a lot of these other people are taking some of his ideas, incorporating their own ideas, and saying that's their model. All right.
Understood. Now let me clarify a few things. First of all, when I mentioned the, for instance, the chart of theories, right? I say right up front, in the last 5 years, and yes, we stand up. I do not say, okay, I do. So am I aware of all these people? Absolutely. And I don't know. I may have that book, but I do know him. I've met him. I did meet the old guard. I was in my mid-30s when I met all these people. And yes, people stand on the shoulders of other people. And so what I would suggest is that is Stephen Rado around, or did he already pass?
You're aware he passed in 2012.
Oh, in 2012. Okay. Well, I have a database of all that information that we keep track of. It's just I'm in contact with literally thousands of guys around the world, guys and gals. So I can't remember all of that. So even my mentor, I don't even know if he has passed away or not. But regardless, what I would say, Robert, is it would be great for you maybe to present this. One of the things you have to understand, we've got a lot of new people who haven't been around. And I know these people and who don't have the book that you have holding in your hand, which I don't know, maybe in my library, because I have a big library. People have sent me a lot of books. And I do know the Aetheron, I've heard of that. It's like the Soliton, I've heard of that, that another person mentioned. So what I would suggest is that you maybe put together a presentation either of his work and or of your work, and let people know about it. We have a lot of ways of doing that. Unfortunately, right now, having that book is not available, I don't think, like on an Amazon or anything, right?
Yeah, it is. Yeah, it's sold. He has 2 books. Yeah, he has 2 books. One is the Aetherokinematics, and the other is Aetherodynamics. Okay. The dynamics one most people don't know about.
So those things are available on Amazon right now. Somebody can buy
Yes,
those.
right now. His son
Okay,
actually is responsible for keeping it going.
Okay, gotcha. Okay, but what I would suggest, and it's just because we have so many things going on, is that we have every Saturday here, and it would be really wonderful for you to present. You could even do 2 Saturdays if you wanted, or one together, present what his work was about, and Rado's work, and your work, whatever, so people can find out about that. It's a different world these days. People have less time. They're going to watch videos like these kinds of things to get a lot of their information. I'm not here to argue that books aren't great. I love books, but I think that's a perfect opportunity to get people to know. And that's what I suggest. So, again, I don't ever intention to leave out the people who have blazed the trail for a lot of these things. I think that if you want to do some type of presentation on that, that would be just really great. So, but okay, and I think my goal is just to get this out here, and I'm get information. And there are just so many people, especially from the old guard, that are out there. It's sad in the sense of we're losing people. We just lost Ron Hatch. We're losing people all the time. People who are whose shoulders we just stand on. People who, like I said, Ron Hatch wrote me my first check for $5,000 to buy a movie camera, which is sitting right back here, for me to make the film Einstein Wrong. And we have this old guard that's going by. That's why do you think that in 2008, myself and Greg Volk spent all of our time trying to document all these people. These people are revolutionaries. They're people that have set the road for all the people that we have today working on things. And like you said, there is something, and I agree with 100%, and that is a lot of people don't read about other stuff. What happens is they'll get into what they're doing, not look at other people's work, and not try to understand where their stuff fits in the context of what other people are doing as well. And that becomes sort of brittle. But then again, the world's a free place where you can read Rado stuff. You can do it. Another person's going to go on another person's route. But if you think that this is something that people should know about, well, let's talk about it offline and maybe get together. I'd love to have you, Robert, come on and talk about all this. Is that a possibility?
Yes, that's a possibility. That sounds great. I look forward to it.
Okay.
All right, Dave, it was a pleasure. Have a great day.
All right, thank you too. Okay. Okay, and I've got to do all this. Ooh, people are moving. All right. People are moving in the green room. So, yeah, I mean, it is absolutely true. I have been around these people for a long time. It's been really hard for me emotionally to see so many of them go. I mean, I miss so many of them. I miss having Peter Marquardt, one of the most fascinating people I've ever met in natural philosophy, a true philosopher from Germany. He has a PhD, and he just doesn't have much in his life. He doesn't even have his own computer that's very good. And, I miss these people. Bob Heaston, working on the maximum force of gravity, talking about C squared. The aetherists in the beginning of the NPA, there were quite a few of them. There was a big rift in the MPA between the two. So there's just so much there. And yet we have to go forward and try to interest new people. One of the things, Bob, what I think would say to you, Bob, is we got to get new people. And that's what we're doing with this new medium. I mean, we've got people on 3 channels watching us right now, Facebook, and 2 YouTube channels live across the world. We're bringing in new people. If you go to our website, you can see all kinds of new names and new critical thinkers out there. And one of the things that I think the biggest, message I got from the old guard of the MPA and the people who Greg Volk and I so admire, who have been so brave to go against the mainstream for all these years. One of the things they say, Dave, we need new people in here. And that's one of my main goals, is to try to first document what we have, which we have in our database in the wiki, which Stephen Rado is part of that. And his book, I'm sure, is part of that, because we cataloged all this. To go to wiki.naturalphilosophy.org. And check that out. The next thing was to get it on the internet so that people can see that. So we gathered it up. We did that. And the next thing for us was to get out there in the way the world's working today. The idea that before, again, I said this many times, literally the MPA was started on a typewriter and telephones. That's how they did their work. People like Stephen Hurl, who wrote The Dinosaurs and Expanding Earth. I asked him, how did you do research? He went to the library. He asked librarians. They looked up references in books and tried to find people and get to know where they were and talk with those people. And so, that's what I'm trying to do. And I know I'm not going to do it perfect, for sure. And I'm not going to do everybody justice that should get justice. But hopefully, as we grow what we're doing and we get new people, that people will see these things. And what I would recommend to everyone who's a new critical thinker is to go to our Wikipedia, take a look around, look at what people are doing, buy one of the proceedings. We have our proceedings on the internet. Take a look at those. What are people writing abstracts about? You can find it on our Wikipedia. All the abstracts that we've ever pretty much written are on the Wikipedia. There's like almost 3,000 of those abstracts there. This is just the abstract. There are some papers and a lot of links to those papers. But, it's tough. It's tough to try to do all this. And right now, I'm been pretty much on my own. I have gotten the financial support, meaning not me, but to keep these things that even this, we are literally spending over $200 a month on expenses for web servers, for software, for StreamYard, for Overleaf, for our proceedings, blah, 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 blah. And I have people just to keep the machine going. So hopefully, as we grow and as people are less and less fearing of criticizing mainstream, that we realize that we're trying to do our best. So I'm not worried about have people absolutely telling me that we need to look at someone. But if you do need to, if you have somebody out there that you think should be looked at, then come to me or send me an email and we'll take a look and have you maybe present things. See, there we go. That's what I need. Thanks for all you're doing. Well, at least that's one person. Anyways, I do it because I have an empathy for this. And like I said, my father and I have our work, but it's just one part of the puzzle. So anyways, we have the green room again. We have 1, 2, 3, 4, 5, 6, 7, 8 people in the green room. So if you're in the green room and you want to make a comment, I think I have one. Oh, hey, one of our speakers coming up. Unmute there. One of my favoriteest older guard, and that's a 60-year-old talking to an octogenarian. But welcome, Nick, and we're really looking forward. I'm really looking forward to your talk on time. So you had some comments on all this here.
Yes, I'm going to talk about a different perspective of the ether, and we have to be careful about terminology, as you said, David, as I'm not talking about ether in terms of light directly, but in Chaffee's discussion, he talked about, or that short video you had, he talked about the Michelson-Morley experiment and how that allegedly didn't detect an ether, although it wasn't a totally null result. It just wasn't the result expected if you were assuming that it was going to detect the Earth moving through the ether as it went around the sun. But Michelson-Morley explained the null effect in terms of motion with respect to the ether causing length contraction and clock retardation. So that area, not about light directly itself, but on clock retardation, the empirical data from GPS is quite clear that atomic clock retardation is a function of absolute velocity. And at least in Lorenz's mind, that would be motion with respect to the ether, and it would, and the data shows that is only consistent with motion with respect to a single inertial frame, namely the ECI frame. If you took another inertial frame and used that as the basic for GPS, you would be directing people off into lakes and over cliffs and whatnot.
Right. I mean, you're familiar then with Ron Hatch's work, right?
All of this comes from Ron and I talking, and
Wow.
He's in complete agreement, because basically I'm just drawing from what Ron has informed me about.
He was a Lorenzist too, right?
Yeah, I'm a Lorenzist, as was
Right.
Van Flandern, who was also a GPS consultant as well as an independent thinker. But I'll just mention one thing, and that two parts, and that is if you think of it as velocity with respect to the ether, then it's also velocity with respect to the local gravitational field, which could cause you to think of the gravitational field, and again, I don't know what a field is, as being the ether. And interestingly, in terms of those phenomenon, they are also caused as you go into a stronger gravitational field. Those effects occur, and those seem to be pretty clearly effects of the gravitational field. So one would think that the velocity effect, which is just another part of that phenomenon, would naturally be related to the gravitational field. So I'm just throwing that in as a catalyst to some of your thinking. There is that link to the gravitational field.
Absolutely. And one of the things that I think people, you know best, especially you and Ron, is this idea that when you put a satellite up, you know, a GPS satellite into orbit, and the clock runs slower, right? Is it slower that it runs?
Well, it has two effects. It runs
right.
slower because of its increased rotational velocity, which is inherently absolute, but it runs less slow as its gravitational potential increases.
Right.
And they almost cancel each other out, but not quite. They have to
it's quite interesting.
Difference, yeah.
Yeah, and I think that's where the problem with time dilation, that somehow time changes. And I think that's one of the things that in this group from very early on, I heard the words, probably in the first conference in '96 when I went to it, was hearing clock retardation. And the idea is, when we measure with physical objects and it's affected by gravitational and other things, it's not time that's slowing down. We explain the physicality of why that's happening. It's not somehow an inherent part of the universe where, I don't know, movement somehow changes for some reason, like an Einsteinian theory. So, okay. Well, listen, thank you so much. And we really look forward to you in a couple of weeks presenting. That's Nick. Really a great mind out there. Also, we do have other people here in the green room. So if you're wanting to speak, please raise your hand. I will take a look at that. Let's take a look at some of the, let's see, fields could be objects. Let's see here's somebody talking here. Michelson-Morley experiment measured the speed of light in a smoky atmosphere across valley in California. It was less than a vacuum it used, way more trips. Yeah, I guess one of the problems is when you're looking at measuring anything about the speed of, you know, the light in the Michelson-Morley, there's so much going on there that if you don't have models for even light and or gravity, how are you going to then predict what you are seeing, right? If you don't have a model. And again, Aether is a very popular model. And if you look at it in Aether, and one of the things that aetherists will spend their time doing, and you saw it in Jeff Yee's video, is how do you explain the supposed, null effect of Michelson-Morley, and he was talking about Lorentz contraction in that case. But again, we're going to hopefully learn more about that as things go on. Let's see what else we have here in our young experience. Oh, yeah. Well, this is a real interesting. How can a young, inspiring physicist get experience doing real physics research? Boy, is this a loaded question. If you ask people who've been around a long time, this is big, and that is, first of all, can you even, what are you talking about? Being able to freely think and freely criticize and freely do what you would want. For instance, do an experiment that would go against the mainstream idea. I don't know. If you're talking about physics in general, one of the interesting things is, I know it's a little bit off topic, but one of the interesting things about today's modern theoretical physics is that it does not attract the best minds. Now, they would totally argue against it. The Nobel Prize Committee would totally argue against that idea. But if you talk to somebody like who we're going to have next week, which is Alexander Unziker, he's the first person to tell you that the people who stay in theoretical physics are not the best people. They have to accept a lot of things that are illogical, unconceivable, and things that just, don't even make common sense. If you look at it, that have a lot of contradictory data, whether they want to say it or not, and they then still have to accept that and then continue forward. In fact, there's a rift, and I saw it in my film with my interview with Dr. Kesley, and he was a experimental physicist at Stanford Linear Accelerator who agreed to be in a film called Einstein Wrong because he says he has to unteach special relativity to his grad students, and he and theoretical physicists are at odds. And so the people who are the theoretical physicists are at odds with experimentalists who are at odds with the dissidents. And the problem is where can we go? Do we have universities that allow for free critical thinking and that ability for you to really investigate thoroughly all sides of a matter and say, well, I think gravity is caused by this, and here's my thesis, and I want to write something about that. So the problem is that most people who are very interested in physics, in the actual physical world, they don't go into theoretical physics. They run screaming away from it because the moment they raise their hand and ask a question that contradicts relativity, for instance, they're going to, be told, no, that's right. You have to regurgitate everything on the test. And the reason you don't understand it is you haven't been indoctrinated, meaning you have not accepted all of our logic, learned all our logic, and can repeat all that logic. So, right. I mean, here's some, it's true. Who gives a damn about the Nobel Prize, the Ig Nobel Prize? I don't know. Maybe that's different from the Nobel Prize, but the Nobel Prize. Prizes don't matter, obviously, unless, of course, you're trying to get funding, and then it matters a lot. So let's see what else we have here in our, again, if you're in the green room, want to speak, please raise your hand. I'm going to go back in some of these. I know a lot of people have been putting some of their comments up there. Let's see, I'd like to do. We have people popping in. Cornelius. Oh, I do have. Hey, Harry Ricker. There you are. Hello, Harry. How are you?
Okay, David. Good morning to you. I'd like to comment a bit on some of the issues that came up, clarify some of them if I could.
Absolutely.
One is the issue. I don't think Newton was an aetherist. That seems to be a mistake.
I agree.
That should have been corrected. The controversy is that Descartes and the Hegelians, or the Descartians, were aetherists, and Descartes and Leibniz, actually it was Leibniz, Leibniz was a big opponent of Newton. Leibniz came up with an ether theory of the motion of the planets around the sun. Okay. And that's where the first ether theory is applied in physics, right. And it's applied to explain the motion of the planets around the sun.
Right, and I do remember Leibniz, yeah.
So ether theory has its origins, modern ether theory has its origins in explaining gravity, if you will. Okay.
Right.
And Huygens is supposed to be an aetherist, and Huygens, of course, first came out with the wave theory. Now, I think that theory sort of went away, but then Young, when he discovered the wave nature of light, that sort of brings back the wave medium idea as opposed to Newton's idea, which is that light is a particle.
Right. Right. I think, Newton explained particles were different sizes in order to try to explain the frequency, I think.
I think so, yes. Okay, the other thing I wanted to talk about is Maxwell's theory is an ether theory. Okay, and so by the time Maxwell comes along, you had not Huygens, but Young's experiments with the wave theory of light. So, that sort of gave credence to the idea of a medium necessary for light. Maxwell's theory is an ether theory, if you will, because he postulates a particulate medium in space. So I think an ether theory is defined as a theory which postulates particulate particles in empty space.
Right.
Okay.
And I think the difference in like our particle model is those particles are not necessarily moving and transmitting, but they are in space. So whether or not they're traveling or not, that's the way I look at it.
I'm just going to try to clarify a couple of issues here. The importance of Maxwell's theory is the unification of electricity and magnetism, and any ether theory, in my opinion, if it attempts to do anything, has to explain the unification of electricity and magnetism, and most of the ether theories that are being discussed in the forums that I know of don't even attempt to do that. The other issue is they have to explain the experimental facts. I don't think any ether theories even define what the experimental facts are.
Yeah.
So Ian was the only one who actually talked about that.
Right. And
the experimental facts have to deal with the explanation of why the electric field and the magnetic field are in phase. Okay, because as he was trying to explain it, they have to be, I think he used the word resonant. Okay, because the theory of electromagnetic waves through space is very similar to the theory of electromagnetic waves on transmission lines. That's the point he was trying to make.
Right. Understood. Okay. Yeah, I did understand that. Yeah.
All right.
Yeah, I was talking about laser. Yeah. Go ahead.
I'm just trying to explain what Ian was talking about there. Okay, so if you're going to have an ether theory about light, okay, you have to have it has to be based on the experimental facts. Okay, people don't do that. Okay, they make the experimental facts try to fit their ether theory. Okay, problem number one. Okay,
I agree.
Okay, I agree. To talk about ether theory, you have to talk about what the facts are that your ether theory has to fit. Okay, you don't start with imagining a bunch of particles and then try to make the experimental facts fit your theory of ether particles. That's one of the problems with ether theorists. They don't state what the facts are that their theory has to explain. Okay, there's a lot of facts in electromagnetic theory that have to be explained. Most people just ignore them. Finally, on the laser issue, a laser is a very high, there's a misunderstanding about this. It's a very, very, very narrow beam antenna. Okay, so it does have a spreading of the beam, but because the wavelength of light is very small relative to the size of the aperture, a laser transmits a very, very, very narrow beam signal. It's just like a microwave antenna, except for if you think about the scale, the antenna for a laser beam is, thousands and thousands of miles compared to the size of a typical microwave dish. So you have a very, very, very huge aperture antenna producing a very, very, very narrow beam.
Mm-hmm. Okay. Yeah, I've heard that.
Okay. Now, were there any other issues here that need clarification?
Well, I don't know if there's any other issues. I mean,
again. Okay. Here's the other one. which is regarding Einstein abolishing the ether. Well, there's a lot of truth in that. The problem is that ether theories really couldn't explain the facts of electromagnetism very well. And the problem is, how do you have this medium that transmits transverse electric and magnetic waves? Well, there have been lots of theories put forward by the time Einstein came along, and none of them really were very satisfactory. So I think the issue is, I think it's misleading to say that Einstein killed the ether. The problem was that physicists were having a hard time making ether models work in electromagnetism, and Einstein just sort of removed the problem of trying to do that.
Right. No, I agree with you 100% on that. Yeah, I think that's the correct vision. I think it's easy to put down in a summary what happens, but basically the people who are looking at ether theories that weren't Einstein were looking at these problems, and Einstein sort of, came along and says, oh, we don't have to worry about that, shifted the whole direction, and that got sort of dropped. It's sort of like the expansion tectonics in the 1960s, where the geologists had to be confronted with two things: plate tectonics, which the old guard just didn't go for. They just didn't think plates moved, and they were already reeling with that. And then someone comes along and says, no, it's not even that. It's an expansion. At that point, they're going, oh, that's way too much. We're going to drop the expansion one, even though that's a better model, and we'll go with the less hard one to follow by. So I think the history, unfortunately, I don't know. I think it's more unfortunately that history often, and politics within the system often pushes things into a different direction. But I appreciate your clarifications. Thank you so much. From an electrical engineer, more than less. Ian's also electrical engineering background, obviously, talking about capacitance, right?
Yes, what he was trying to explain was actually kind of confusing, because Krauss, I don't know if you know who Krauss is. I can't remember his name. He wrote this book in the late 40s, 1950s, which is a famous textbook on electricity and magnetism. And he talks about in this book, he tries to make space, he tries to model space, empty, what we call void space, in terms of transmission lines. And that's what Ian was talking about when he's talking about permittivity and what's the other, the properties of space. You have permittivity and what's the other one? The magnetic property of space. And those properties work together to create the ways the electric field and the magnetic field are in phase. Okay, so in a transmission line, you adjust the capacity per unit length of the transmission line and the inductance per unit length of the transmission line, and they're set in a relationship so that you get a resistive impedance along the transmission line. And that makes, in the words that Ian was using, he used resonance, makes them resonant, because when a tuned circuit that has capacitance and inductance in it is resonant, the impedance is a real impedance. It's not a capacitive inductance or capacitive impedance or an inductive impedance. It's a real impedance. And free space has a real impedance.
Okay, I appreciate that. I'm learning much more
ether
about
theories have to agree with that. They have to show that free space has a real impedance. Well, they don't, and that's big controversy over that. So you have to be able to show how ether supports electric field, magnetic field, and they have to be transverse. They are polarized, okay, because we know that we have polarization. And you also have to deal with the fact that you have dual polarization, which means you can transmit radio signals on the same frequency. Radio signals on the same frequency, but in dual polarization. So you can have circular polarization. One, the circle is going clockwise. The other circular polarization is going counterclockwise. They don't interfere with each other. Satellite communications uses this principle. You can also have horizontally polarized and vertically signals on the same frequency, and they don't interfere with themselves. Ether theories have to be able to explain how that happens.
But it's not only ether theory, it's all theories, right?
Well, yes, but the ether theory has the difficulty that because a lot of them are deal with compression waves or longitudinal waves. Okay, they can't explain polarization at all. So if your theory, ether theory, is a longitudinal wave or a pressure wave theory in the ether, that's just dead right at the get-go.
Yeah, well, I think one of the problems is people get caught up in sort of a smaller area of what an ether is. Maybe they're trying to come up with some model for gravity. They don't step back and ask these questions that you're asking. And one of the things is a lot of the arguments you're making, I heard back in the MPA days about ether, and then you'd have arguments between Eberly Spencer and others in the group and talking in these manners. So, okay, well, thank you so much.
The point I'm making here, David, is that you have your theory has to agree with the experiments.
Right,
okay,
absolutely.
So the first thing that you have to do is you have to say, what experiments does my theory have to agree with?
Right. No, understood. That makes sense. And that's something they don't spend a lot of time on. That's I agree. Well, most people with their own theories don't. So, okay. Well, thank you very much. We're coming up to the hour. We got about 5 minutes left. I know there's a lot of chatter going on. I appreciate everybody's input. We do have coming up next week Alexander Unsker. We set a date. He is hard to get a hold of, but hopefully it'll all work out. If not, we'll push that another time. But we did come up with that date, so he'll be coming hopefully next week if his schedule holds. And we're going to be talking about bigger sort of subjects in the area of science. I think I've suggested to him we watch the interview he did with David Woods or something like that. Please don't quote me. And he just go to his website, just look up Alexander Unsker, the Machian, and you will find, if you haven't looked at that particular interview, it's got a lot of hits, a lot of views. It is absolutely... You can watch this guy go from pontificating from on top of his Nobel Prize winning seat to literally leaning forward in his chair with the mic slowly being pulled off and wanting to be handed back to Alexander Unsker, who asks some very basic questions, which just totally blow him out of the water. But as you can see, and I do know, is it's really important that a couple of things I think we need to understand is that ether is a very well, accepted model for the universe amongst dissidents. You can see most people are etherist, a vast majority. But I agree with, in principle, with Harry Ricker, and that is they do not seem to care about the answering basic questions. Does it, they look at Michelson Morley, they'll look at certain things, but there's a whole myriad of things you have to explain. You have magnetism, you have electric fields, you have all of those kinds of things, and then gravity. People are trying to explain that in the middle of all this. There's a lot going on. I just think that we and people who are that are etherists need to step back a little bit and start listening to other people's questions at a very fundamental scale, like the things that Harry brought up, things that I brought up as well that I didn't bring up myself. A lot of people have their objections. There are a lot of people, folks, that don't subscribe to it. And there are new models out there, like my father's model is a different model. And yes, we explain magnetism and fields and all that kind of thing. It's a different model. Is it right? No. Are etherists right? No. That they are models out there. And we need to continually pound on them, because what happens is we become brittle if we don't read about other people's models, if we don't listen to comments that people make and can't address them. If we don't, in this book, we look at the double slit experiment. We show how our model works with electronic circuits and all the components of electronic circuits from an electrical engineering point of view. We tell you all kinds of things that have to do with the real world. If you gotta at least try to address them, right or wrong. But I think we gotta be, I'm gonna say it, folks, a lot less arrogant about our own theories. I mean, in my day, this book sitting right here, there are times during the day that I said, this is a bunch of baloney. None of this is right. And then other times I say, there's a lot of good stuff here. We need to at least tell the world what we think are some of the things that we've found. But it's just, a lot of people are just so certain. I just scratch my head going, wow, I mean, you're that certain? I mean, again, the goal is not to convince people. The goal is to try to find better models, to find things that are going to advance science, that are going to try to explain and give physicality to all these things we talk about. Because I'm tired of hearing about charged particles in fields and moving particles in fields and magnetic and electric fields. And we talk about all these things without any type of model. And at least everyone is trying to do that. But as dissidents, I will just tell you, step back, take a deep breath. You're not right, you're not wrong, but there are different things out there. We need to pay attention. And I will say it, I've said this so many times. You sit there and you work on your model, and you're convinced you've got in your own world of what you're doing, your model, your vocabulary of that world, and you don't look at the outside of what's happening around you. Someone's going to look at yours, really study it, take a piece of it, okay? I know that when people are saying robbing it. No, science is free. If you see a good idea, you're going to use it. They're going to use it, and they're going to do something maybe even better than you. And you're going to say, well, don't put the blinders on. Keep yourselves up and circulating in the world. So remember what I always say, stay critical, stay thinking. I'm Dave D. Hilster. I'm your science therapist trying to get you to the promised land of becoming critical thinkers. I'm not telling you what to believe. I'm trying to get you to find that out yourself. Ciao for now.